quality of our St. Johns River at the surface and at the bottom, right off of Jacksonville University's docks. Every water body has a vertical water column, which differs in physical, chemical, and biological characteristics, and it extends from the water surface all the way down to the bottom. Now, not every water body is uniform. There are valleys and peaks, channels and shoals. So the results we find today are not going to be the same if we were to do this same water quality testing, even just a few feet off of the dock from where we're sampling. The littoral zone is the zone closest to shore. Here, light reaches all the way to the river's bottom and supports rooted plants. As the river drops in depth, you move into the limnetic zone or photic zone. This is the layer of open water where photosynthesis occurs by phytoplankton and where primary consumers such as zooplankton and small fish inhabit. The limnetic zone is shallower in more turbid water such as the St. Johns River, as light has a harder time penetrating to greater depths. The profundal zone or aphotic zone is where the water is too deep that not enough light can support photosynthetic organisms. You will mostly find consumers that will either travel to the limnetic zone to feed or rely on organic matter drifting down to them. This zone includes the lowermost region of the river called the benthic zone. This zone is where you find bottom feeders like flounder, crabs, and shrimp, and large populations of bacteria that decompose any dead material. The water quality parameters we're going to be measuring today are going to be temperature, salinity, dissolved oxygen, and pH. To get our surface water sample, I'm just going to use a bucket to skim the surface. But for the benthic sample, I need a special piece of equipment called a Niskin bottle. And a Niskin bottle is just a plastic cylinder. It has stoppers on either end, and it's attached to a string. When I lower this into the water, the stoppers will be open, and when I've reached the desired depth, I'm going to send down what's called a messenger, and it's going to push a button, and it's going to close those stoppers. So let's go ahead and collect our water samples. We're going to lower our Niskin bottle into the water. You can see the stoppers are in the open position. How I know we've reached the river's bottom is that the line will actually go slack. All right, so there's a little slack in the line. I'm going to attach the messenger. Make sure it's closed and locked in place. And I'm going to send it down to close those stoppers. What you're looking for are the bubbles. There they are. We're going to raise it back up and we should have our benthic water sample, which we do. We've performed our water quality tests using the equipment that we've used in previous water quality videos. And so we're just going to display the results on the screen and quickly talk about the concepts of why there's a difference between the water quality at the surface and the water quality at the benthic zone. So let's look at temperature first. Temperature, remember, cold water is more dense than warmer water, so it's going to sink. This differential heating is called convection currents. It happens in our atmosphere and it happens in the mantle of our Earth as well. Let's look at salinity next. Salinity, the higher the salinity there is in the river, the denser it's going to be, so it's going to sink, which is why we see the benthic zone having higher salinity levels than the surface. The next test we're going to talk about is dissolved oxygen. Colder water does hold dissolved oxygen more, but remember that light cannot reach the benthic zone. So it's not going to be able to provide any sort of habitat for photosynthetic organisms. So our dissolved oxygen levels are going to be lower the deeper you go in our river. And the last one we tested for was pH. And pH at the benthic zone is going to be lower than the surface because of the rate of decomposition that happens. That's where we find those large populations of bacteria decomposing dead material. The quality of our water column can change seasonally, geographically, and even the distance we travel from shore. To see each test done in more detail and the associated river issue with them, please watch our other water quality test videos on our website. So why do scientists care about studying water quality at varying depths? Data collected from studies such as this can provide a more detailed understanding of a water body's characteristics through the entire water column, which is crucial for understanding the physics involved. The physics, in turn, allows scientists to understand why particular chemical and biological components are present or not present at different depths. St. John's Riverkeeper partners with scientists here at Jacksonville University and at other universities in the watershed to study the health of the St. John's River holistically. Studying water quality at various depths can provide valuable information when it comes to understanding river issues such as saltwater intrusion, nutrient pollution, and water withdrawals. Thanks for joining us today to compare the quality of our water at the surface of the St. John's and at the bottom of our St. John's. And we'll see you again on the river soon.